Okay, dear students, now we are in question number 5. So here you are asked to find the slope of the tangent line to this curve at the point 0, 1. So in order to determine the slope, what you need to do is you have to look for dy over dx here, because slope by definition is change in y over change in x. Because of this, we need to undergo implicit differentiation here. So this question number 5 requires the concept of implicit differentiation, the one you studied in your classroom. So now what is going to come as a solution is the following one. So you need to undergo derivative both sides. So as you are applying d by dx both sides, you are having this expression. As you see, d by dx of the left expression is equal to d by dx of the right one. So for this you need to use product rule, and the derivative of x with respect to x is 1, so 1 times e the power of y is going to come, and then plus is used. X as a multiplier is used again, and the derivative of e the power of y with respect to x is going to be e the power of y dy over dx. You do the same for these two, but as you are coming to this side, the derivative of a constant 1 is 0, so clearly this goes to 0. So this is going to be like this. Look, the derivative for the first term, this one, x times e the power of y, is going to be the expression inside this bracket. So the derivative of this with respect to x is 1, and 1 times e the power of y is e the power of y. Then you do have plus. Now you will take x as it is, then it is e the power of y's term to be derivated. So the derivative of e the power of y with respect to x is going to be e the power of y itself, but you need to have dy over dx here because the derivative is with respect to x on y, so you need to have dy over dx. Then because of this plus sign, you're having plus here, then you need to derive again this by using some rule of derivative. So again, applying product rule for this, you do have to see such expression. So as you are deriving this with respect to y, with respect to x, it will be dy over dx. So the multiplier e the power of x comes as it is. Then plus comes because of this derivative rule. Then as you are deriving e the power of x with respect to x, as you know, the derivative is itself e the power of x, but you will take y as it is as a multiplier. So everything is available now. This is 0 because the derivative of a constant 1 is 0. My dear student, that our intention is to determine the slope, so we are interested to know what dy over dx is going to be. So let's collect like terms together here. I'm having dy over dx here, dy over dx here, so I may take dy over dx as a common out, and then take x e the power of y plus e the power of x as a multiplier. And I can move this e the power of y to the right and turns to be negative e the power of y. And I can also move y e the power of x to the right, and it's going to be negative y e the power of x. So both are going to be negatives. So in doing this, I can have this one, dy by dx, the slope I'm talking about comes here, change in y over change in x, and this is negative of y e the power of x plus e the power of y divided by log x e the power of y plus e the power of x. Now look, we are interested to know the slope at a certain particular point, and the point here is at 0, 1. So in order to know the slope, you need to substitute 0 in place of x here and 1 in place of y here. So in doing so, you can obtain slope at 0, 1 as you see. Look, when you put 0 here in x, e the power of 0 makes 1, and 1 times 1 is 1. And here y is what, students? 1 again, so this is going to be e, right? It will be e, so this is going to be again x times e the power of y, and again this is going to be like this. Your x is 0, so 0 times this is 0, so 0 is going to come, plus e the power of 0 is 1. So what we need to adjust here is, look here, your y is 1, so e the power of 1 is going to be e, right? So dear students, now you see you can obtain the final answer to be negative 1 minus e. Therefore The slope at this particular point, at the point 0, 1, is going to be negative 1 minus e. That is good. Now proceeding to the next one, we have another question, and that is question number 6, and that is about the derivative question. You are given that if derivative at a is 10, then the question is to know what is the limit of f of a plus 3h minus f of a over h as h approaching to 0. So basically, this can be done as follows. We know that the derivative of a function at a is defined as the limit of f of a plus h minus f of a over h as h approaching to 0. This basically is a definition for a derivative directly taken from the definition. And we have been told that this derivative is 10. Here it is, a given information. Now, next from this, in order to come to this one, let's assign x to be 3h, students. Here we are having 3h. What we were having here was h, but now it is 3h. So let's make this to be x. Let x be 3h. And from this, h is going to be 1/3 of x, matter of dividing the whole by 3. So as h approaches to 0, as h runs to be 0, 3 times 0 is 0, so x again runs to be 0. So the question we are having here, the limit of f of a plus 3h minus f of a over h as h approaching to 0 is going to be like this. The limit of f of a plus, look in place of 3h we are having x minus f of a, again in place of h we are having 1 over 3x. So students, from this you can move these 3 up and make 3 times the limit of f of a plus x minus f of a over x as x approaching to 0. Dear students, this is nothing but it is a derivative of f at a. The reason is it's a matter of changing, okay, the symbol here or the letter here. If you change this letter by any one, no problem. It can be what? It can be considered as the derivative of f at a. For example, you may take, okay, a letter k in place of h. You may have, for instance, a limit as k approaching to 0 of f of a plus k minus f of a over k. This is f derivative at a. So whatever variable you may use in place of h, it doesn't what? It doesn't make your derivative definition different from the previous one. So now what has been used in place of h here is x. So if you use x throughout, the limit as x approaching to 0 of f of a plus x, look here, this one, minus f of a over x can come. And this represents nothing but it is f derivative at a. It's a matter of changing h by x, nothing else. Okay? So this is going to be 3 times f derivative at a. But we knew what f derivative at a is. It's already given. It has been said 10. So this is going to be 3 times 10, and finally 30 can come. So students, you are supposed to write 30 there in your blank space. Next from this, question number 7 is going to come, and here we are going to answer a question involving continuity. So this function, as a piecewise function, it has been defined this way. You've been told that this function is sine x over x for any value except 0. Except 0, the function is sine x over x. And for this particular case, the function is 2m plus 7 when x is 0. So you are asked to determine the value of m for which this can be continuous at 0. So dear students, this function is continuous everywhere as you see, except 0 because it is broken at 0. It has been said that the function is sine x over x for any value except 0, and when it is 0, it is 2m plus 7. So we have to create a case of amendment for this function to be continuous at number 0. So to do that, what we need to do is we need to recall the definition for continuity. So the solution goes like this. A function f is said to be continuous at 0 if the limit of f of x as x approaching to 0 is the same as f at 0. So if this is so, the limit of f of x as x approaching to 0 from the right is the same as the limit of sine x over x as x approaching to 0 from the right. Mind you that approaching 0 from the right is nothing but using numbers like 0.1, 0.01, something like that. Numbers close to 0 but greater than 0. So during this case, your function is the upper one, sin x over x, because when x is different from 0, that is to say when you are approaching to 0 doesn't mean that when x is 0, right? So you are using numbers close to 0. So you see the upper one is going to be used, sin x over x. The lower one is used only when x is 0. Since x is approaching to 0, it doesn't mean that x is 0. So the function is sin x over x. So sin x over x equals 1 is going to come. Sin x over x is going to come, and we knew that this is 1, so this result is number 1. But as I said here, you see, this has to be the same with f at 0. But we knew that f at 0 is 2m plus 7. Here you have. So necessarily, in order to know what m is, you have to take this equation, that is 2m plus 7 equals 1. So moving 7 to the right, it will be 2m equals minus 6. And from this, m is going to be minus 3. So the value of m is going to be negative 3. So you need to put negative 3 in place of your blank space. So having this into account, what comes next is question number 8. Given that f of x is the integral of cos 2t plus t squared dt from x cubed to x, then you are asked to find f derivative at 0. So dear students, in order to answer this one, you need to go back and you need to read about fundamental theorem of calculus 2. So read that and apply the concept in order to answer this one. So the solution goes like this. Using fundamental theorem of calculus, you see that if f of x is given by this, the derivative of this can easily be obtained by using this. F derivative at x is going to be, look, as you are derivating this, derivative and integration are anti to each other, so one can cancel the other. So the integrand expression is going to come as it is. But you need to know that. You see, we are going to substitute x and x cubed one after the other, taking minus into account, okay? And you need to know also that chain rule must be used. After substituting x, we need to carry out the derivative with respect to x. And later, after substituting x cubed in place of t, we need to carry out derivative with respect to x on x cubed. So f derivative at x is going to be like cos the integrand. Take the integrand as it is without any sort of confusion. So cos is going to come as it is, but in place of t now, take x. 2x plus x squared, you see? Then we have to derivate the upper one with respect to x, and that is d by dx of x. Basically, it is 1. Then minus comes, because of the fundamental theorem of calculus. Then again, for this case, you need to take again cos as it is, but in place of t now, it is x cubed to be used. So cos 2x cubed plus, now here in place of t again, I'm going to use x cubed. So x cubed, the power of 2 makes x the power of 6. You see? Then since I'm substituting x cubed in place of t using chain rule, I need to derivate x cubed as you used derivating with respect to x before. So this is going to be d by dx of x cubed. So from this, what can be obtained is the following one. So f derivative at x is going to be cosine of 2x plus x squared. So the d by dx of x is 1, and minus what is going to come next from this is this. F derivative at x is equal to cosine of 2x plus x squared minus cosine of 2x cubed plus x to the power of 6 times 3x squared, because the derivative of x cubed is 3x squared. Now everything is done, okay? So what we are asked here is to determine the derivative of f at 0. So from this, f derivative at 0 is going to be, put 0 in place of x, cosine of 2 times 0 plus 0 square minus cosine of 2 times 0 cube plus 0 to the power of 6, 3 times 0 square. So look here. Since this one is 0, the whole goes to 0, because 0 times this is going to be 0, but here 2 times 0 is 0, plus 0, 0, cos 0 can come. So f derivative at 0 equals cos 0 can come, but we know that cosine 0 is 1, so the answer is going to be 1. I hope you have understood it.